like I've already said, in this section, you are going to learn how to establish an identity. Okay, we have not done that yet. All we've done from example 1 is learn some different algebraic techniques for manipulating trigonometric expressions that will be useful when we actually get to establishing identities. Okay, so the next thing we're going to do is talk about what does this word identity mean. Okay, so we're going to talk about what is an identity opposed to a conditional equation. Okay, so it says two functions f and g are identically equal if f of x is equal to g of x for every value of x for which both functions are defined. Such an equation is referred to as an identity. Okay, so the way you can think of an identity, okay, it's going to be an equation that is true for every value of x or theta or whatever variable you're using. It is always true, okay? A conditional equation, okay, that is explained right here in the second bullet point, and it's not very telling. It says an equation that is not an identity is called a conditional equation, okay? So a better way of thinking about a conditional equation, okay, it's going to be an equation as well, so you're going to see an equal sign. So this is an equation that is true for only one or more x values or theta values or whatever variable you're using, okay? It's only true some of the time. Like x has to be a certain number to make this statement true, okay? So identity is an equation where it's true for every value of the variable. A conditional equation means the equation is only true for certain values of the variable, okay? When we did section 3.3, where we learned how to solve trigonometric equations, those were all conditional equations, okay? We had to solve to figure out what value or values of theta made the equation true. It didn't work for every theta value, okay? We had to figure out when did it work and when did it not, okay? So in the box below, I'm going to give you some examples of identities and some examples of conditional equations so you can kind of see the difference, okay? So first, I'm going to start off with identities. I'm going to give you an example that's just from plain algebra. It doesn't involve any trig. If you take x plus 1 in parentheses squared, okay, and you were to FOIL this out, okay, you would get x squared plus 2x plus 1 if you FOILed it out and you simplified, okay? This is an example of an identity, okay? It is always true no matter what the x value is, okay? Now kind of switching gears and doing this in terms of trig, an example of a trig identity, one that we've already met, one of the more popular ones, the Pythagorean identity, okay? Sine squared theta plus cosine squared theta. That is always equal to 1, no matter what the theta value is, okay? I'll give you one more, and then we'll look at conditional equations. You can look at a reciprocal identity that we've learned, okay? If I have the cosecant of theta, okay, that is always equal to 1 over the sine of theta, no matter what the theta value is, no matter what angle you're using, okay? So those are some identities, both from just algebra and from trig, okay? So now turning to conditional equations, remember these are going to be statements, equations that are true only for certain variables, okay? So I'll give you one from just plain old algebra. If I have 2x plus 5 is equal to 0, okay, you know you can solve this equation. It's only going to be true if the x value is negative 5/2, okay? No other x value is going to make this work. Like if you plugged in x equals 0, you would get 5 equals 0. That doesn't make any sense, okay? This equation is only true. It's only true under the condition that x is negative 5/2, okay? Switching gears to trig, okay? If I give you the equation, when is the sine of x equal to 0, okay? So this is something you learned how to solve in section 3.3. If you, and I'll just write down the answer if you want to go back and test yourself, you know, make sure you learned what you needed to learn out of section 3.3. This is only going to be true if x is equal to some integer multiple of pi, Okay, so the x values here have to be of the form k times pi, where k is an integer. Okay, so again, only certain x values make this statement true. Okay, not every angle that you take the sine of is going to return a value of 0. Okay, I'll give you one more. When is the sine of theta equal to the cosine of theta? Okay, again, it is not true that if you take an angle, its sine is always going to be equal to its cosine. Okay, again, that makes this a conditional equation. This is only true if theta is equal to pi over 4 plus integer multiples of 2 pi. Okay, so again, where k is an integer. Okay, so again, these last two equations, okay, these were things we learned how to solve in 3.3. Okay, they are only true for certain values of the variable. Okay, so in the rest of this section, we're going to work with identities. Okay, these are going to be equations that are true no matter what the value of the variable is. Okay, so make sure you understand what is the difference between an identity and a conditional equation. Okay, it does not make sense to solve an identity because it's true for every value of the variable. Okay, it makes sense to solve a conditional equation for the variable because it's only true for certain values of the variable.